Okay, so now we're going to try graphing a reciprocal of a quadratic function. So again, what I've done first is started with the original function, y equals negative x squared plus 4. So here's my parabola. A few important points you want to make sure you have on your sketch is your vertex, wherever that is, and also the x-intercepts. These are all important points that will show up somehow on your reciprocal as well. So what we should start with is identifying the zeros here. Now, if you're just strictly doing this algebraically, you want to make sure you're able to put this into factored form. In this case, we're working with something that is actually a difference of squares, although I would probably write it first by factoring out the negative sign. So negative x squared minus 4. And that way you can see a little bit easier where your zeros are going to be. So there's factored form for you. And you can see we have zeros at -2 and +2. So I'm just going to write in coordinates for those points. Now again, on the reciprocal function, what's going to happen is the y values here will flip. They'll become the reciprocal. But when you take a number like 0 and you flip it, it actually becomes 1 over 0. So if you write a number like 1 over 0, that's not something we can evaluate. And for that reason, they show up as vertical asymptotes. So on our graph, we're going to see vertical asymptotes at x equals plus and minus 2. So the first thing I'm going to do on my graph is take a minute and draw in my vertical lines, dashed lines, and label them so I know where my vertical asymptotes are going to be. Okay. So now that that's done, I like to look at the positive and negative intervals next, because that's a characteristic that is also shared between the original graph and the reciprocal. And the reason for that is because when you take the reciprocal of a number, you don't change the sign. So any of the y values that were negative, let's pretend it was -2, when I take the reciprocal of that value, it's -1 over 2, it's still negative. So any part of the graph that was negative on the parabola will still be negative on the reciprocal. Likewise, any numbers that were positive, even if they were small numbers, when you take the reciprocal of a positive number, it stays positive. So any y values that were already positive on the parabola will remain positive on the reciprocal as well. So for that reason, when I look at this parabola, I can see that as soon as we cross the x-axis, I'm changing from negative values to positive values. So everything before I hit this x-intercept is going to stay in this section. It's going to stay negative. So I'm just going to shade in the part of the graph that I want my reciprocal to stay there, to stay in. So negative y values, my reciprocal will stay here and be negative. Just like on the other side, once we pass back through the x-intercept, anything here that had a negative y value will also stay negative as well. In between, we've crossed into positive y values, totally above the x-axis, all coordinates with positive y values. So my reciprocal is going to stay here as well because it's going to have positive y values also. So I shaded in just to remind myself of where I need my reciprocal to stay. So that means that any area that's blank is not going to have any graph in it for my reciprocal at all. So that means that my positive intervals on this graph will go between -2 and +2, between my intercepts. So I'm just going to write that here in interval form. That means also on my reciprocal, it's going to have the same positive interval also. Now my negative interval, I have 2. I have everything on the x-axis leading up to -2. So I'm going to write -infinity to -2. But it's also going to have negative y values from +2 all the way over to infinity. So that's a second interval that I'm going to have there as well. So again, that means that on my reciprocal graph, I'm going to have the same 2 intervals. It'll be negative in the same section. It's going to be and positive in the same section as well. So they match. Okay. So now I'm going to look at one, just before I do increasing and decreasing intervals, I'm going to look at one key point on my parabola, and that's the vertex here. Now the vertex here is at 0, 4. Not only that, it's an absolute maximum value on this parabola. So I'm just going to make a note here that it's an absolute maximum value. Now on the reciprocal, this point is going to flip. It's going to become the opposite. Well, the reciprocal. So instead, it's going to be the coordinates 0 and 1 over 4. And what you're going to see in a minute is that instead of becoming a maximum value, it's going to become a local minimum value on my reciprocal. So if you don't know this right away, that's okay. Within a few seconds on the sketch, you'll see that. But you should at least be able to take the coordinate 0, 4 and turn it into 0, 1 over 4. So on my graph, I'm just going to plot approximately where 1/4 is on my y-axis so that I can aim for that point when I'm making my sketch. Now, intervals of increase and decrease. When I'm looking at my interval of increase on my parabola, I know that it starts all the way over here on the left side of the graph because of the way this arrow is pointing, and I'm going to increase up until I hit my vertex. So everything from the side with negative infinity all the way up to when x becomes 0, this whole left side of the graph is always increasing. So I'm going to write my interval of increase as all the x values that range from negative infinity to 0. The y values are totally increasing over this entire interval. Well, on the other side of the graph, after I hit my turning point, all the y values are decreasing on the other side. So I know my interval of decrease will start at this x value of 0, right in the middle, and for the entire right side of the graph, I'm going to be decreasing. Now, on my reciprocal, this is different. It's not the same as the parabola. So what I have to do is switch this characteristic. And the reason why we're switching is because even though the signs don't change, hence my positive and negative intervals, the size of the number clearly changes. So if I was going to write out a list of numbers that were decreasing, so 5, 4, 3, 2, these numbers are clearly decreasing. But when I take the reciprocal of those numbers, 1 over 5, 1 over 4, 1 over 3, and 1 over 2, these values are actually increasing. So the reciprocal does the opposite to what the original number does. A decreasing set of numbers as a reciprocal set becomes an increasing set of numbers. So because of that property, these are going to flip. Now I'm not going to write them in just now because I have to be careful with those asymptotes. I can't include those numbers on my intervals. So if I look at the graph though, I know I have this negative section of my graph, so I have to stay down here in this negative section, but instead of increasing like the parabola is doing, I have to decrease. I have to do the opposite. So I am going to change this to a decreasing arm of my reciprocal. Okay, and in the middle here, two things are happening. My parabola is still increasing until the vertex, then it switches to decreasing. So I'm going to do the opposite. I'm going to decrease away from the asymptote. This is where I need to hit that 1 over 4 that we talked about, and then I have to increase coming the other way. And again, I should have a point of intersection somewhere around my y values of 1. So I'm just going to kind of make a note of those. But I'm going to decrease away from the asymptote, hit 1 over 4, and increase towards the asymptote on the other side. So that's my middle section of my reciprocal. And over here on this side of the graph, I have a decreasing arm still on my parabola. So I know that I have to increase and do the opposite on my reciprocal, but still stay in my shaded negative section of the graph. So all three of these parts put together make up our reciprocal function, and I can write in my intervals now pretty easily, as long as I'm careful that when I write my intervals of increase on the right-hand side, I have to break at that asymptote. And the reason is because there's no value there on my reciprocal. There was one on the parabola, but there isn't one on the reciprocal. So I have to go from 0 to 2, and I have to go starting again at this line at 2 and go to infinity. For my decreasing interval on the left-hand side, I'm decreasing from my negative infinity side until negative 2, but then again I'm stopping for my asymptote, and then I'm decreasing from negative 2 to 0. Again, these are x values, so be careful that you're writing in your x values in your interval. And there's your reciprocal function. Good luck graphing on your own.